Dear learners, in this video I am talking about the assignment problem. At the end of this video, learners will be able to formulate an assignment problem, determine the optimal solution using Hungarian method, obtain the solution for special cases of assignment problem, that is maximization problem and unbalanced assignment problem. Assignment problem deals with allocating various resources to various activity on one-to-one basis. This allocation may be between missions to job. For example, if we have a set of missions to be assigned to set of jobs, in that case we can use this assignment problem. This allocation may be between also jobs to men, the product to factories, orders to quotations, assigning salesmen to sales territory, vehicles and drivers to different routes. For example, you are a manager of a company or a salesperson of a company. You need to purchase one product from the supplier. There are two suppliers who has given the quotation, one supplier with 250 rupees and another supplier with 300 rupees. For minimizing the cost of purchase, you will be purchasing this product from supplier 1 because that will minimize the cost. For example, now you need to purchase two products from two different suppliers. At that time, you will see the cost of quotation. The product 1, you got the quotation from supplier 1 as 250 rupees and 300 rupees, and product 2 you got the quotation from supplier 2, that is 300 rupees for the first product and 250 rupees for the second product. In that case, which product you will purchase from which supplier? Generally, the first component, first product is the less quote cost. The first product is less quotation cost from supplier 1, and the second product is having a less quotation cost from supplier 2. In that case, you will be purchasing product 1 from supplier 1 and product 2 from supplier 2 in order to minimize the cost. So let us say now the cost has been changed. Now the revised cost are like this. The supplier 1 given the quotation for first component, first product 250 rupees and second product 280 rupees, and second supplier given the quotation as 270 rupees and 290 rupees for the second product. Now if you compare the cost, both the products are cheaper at supplier 1 and both the products are costly from supplier 2. In that case, both the product you will be purchasing from supplier 1 in order to minimize the cost. Now if I put a condition to purchase one component, one product from one supplier, then how you will select the suppliers? Now if I put a condition only one product you need to purchase from one supplier, then you will see out of all quotations which one is the cheapest one. Then the 250 rupees is the cheapest one, that is from supplier 1, so you will purchase. And the for product 2, even though the cost is less for the supplier 1, because you can't purchase product 2 also from supplier 1, you will go with the second supplier even though it is costing little higher. So in that way you will be minimizing the cost of the purchase. This way we are going to solve. So if suppose if there are only two components, it is very easy to analyze and see. If there are 10 products, you need to purchase from 10 different supplier with the optimum cost. In that case, we need to make a standard procedure to minimize the sales cost. So that is why there is a method is developed in order to solve this assignment problem. That method is called as the Hungarian method. According to this Hungarian method, we will be solving the assigning the components in this manner. First, whatever the data you are having, that everything you will be writing in terms of a matrix. For example, now the product 1 we will call it as a P1 that will be costing from supplier 1 as 250 rupees and supplier 2 from 280 rupees. And product 2 P2 is the quotation cost is 270 rupees from supplier 1 and 290 rupees from supplier 2. So in this way you will be writing the full data in terms of a matrix. So this is called as the formulation of assignment problem. So then once after you formulate, you will be solving the assignment problem. So now how to solve according to Hungarian method. So first you will be seeing the each row and find out what is the minimum value in that row. So if you see the first row, the minimum value is 250 rupees. And if you see second row, the minimum value in the entire row is 270 rupees. So identify the row minimum value and subtract that row minimum from each element of that row. And then if you subtract from the first row the 250 rupees from every element, then the 250 minus 250 it becomes a 0, and 280 minus 250 it becomes a 30. From the second row the minimum value is 270 rupees. You subtract all the elements from every element, you subtract 270 rupees. Then 270 minus 270 it will become 0, and 290 minus 270 it becomes the 20. Then the next step is identify the column minima. So identify, go to each and every column and identify what is the minimum value in the respective column, and subtract that minimum value again from each and every element in the column. So if you subtract the first column, the 0 is the minimum. If you subtract it, it will become a 0 only. And in the second column the minimum value is 20. So if you subtract 20 from every column, 30 minus 20 becomes a 10, and 20 minus 20 becomes a 0. Now the third step is you need to allocate the assign the products to supplier based on the zeros available in the matrix. Now if you see the first row, in the first row only one 0 is available in the entire row. So that means the product 1 you need to purchase from supplier 1. So once then you will be allocating. When you allocate this product 1 for the supplier 1, then you will draw a square box. Then the supplier, from supplier 1 we can't purchase the product 2, so you will be the cancelling that 0. Then if you come to second row, so in the second row the product 2 having a 2 zeros, but first 0 you can't assign because that is already cancelled. So then if you will go to second 0, that means the product 2 you can only purchase from supplier 2. So in this way you are going to solve the problem. Now after assigning this 0 to second component, now we need to see what is the total cost. Now the total cost, wherever the allocated zeros are there, and you go to the initial matrix, and in the initial matrix yet the allocated zeros, what are the values, those values you need to add. Then you will get the final minimum cost, that is 540 rupees. This 540 rupees is the minimum cost if you are abiding to the rule of purchasing one product from one supplier. So this way you will be solving the problems according to Hungarian method. Now let us see what is that Hungarian method procedure. So the Hungarian method having there are 5 steps. The first step is find the smallest value in each row and subtract it from every element in that row. The second step is find the smallest value in each column and subtract it from every element in that column. The third step is draw the minimum number of horizontal or vertical lines needed to cover all zeros in that matrix. Then if the number of lines are equal to number of rows or columns, an optimum assignment is possible. Then you assign the task. If not, you go to the next step. The next step, fifth step says find the smallest uncovered value in the matrix, subtract it from all uncovered element, add it to the element at the intersections of the line. Repeat step 3 to 5 until the required number of assignment is found. Finally, assign the task by selecting zeros, ensuring no row or column get more than one assignment. So here we need to remember 5 points. So if you see the 5 points, the first point, you need to identify what is the smallest element in the row and subtract that row, that all the elements of that row from the minimum value. And in that way, all rows will be, in all the rows, smallest value will be subtracted. So that then you go to the column operation. In the column operation, you first go to the first column and identify what is the smallest value and subtract that value from every element of that column. Likewise, you subtract in all the columns. Then the third step is draw the horizontal and vertical lines such a way that it covers the all zeros. And when you are drawing these lines, you need to draw minimum number of lines. That means where the maximum zeros are there, that we will first draw the line. Likewise, you will be covering by drawing the horizontal and vertical lines. And when you are covering, there are some elements which will not be covered, for example, and let it be. Then if the fourth step is when the number of lines and horizontal and vertical lines together, if the number of lines are equal to number of columns, then the optimum solution is assigned. Then you can assign the task. If not, you need to go to the fifth step. The fifth step says that identify the uncovered elements. I told you, when you draw horizontal and vertical lines, minimum number of lines, then we will not get the optimum solution when there are some values are not uncovered. So you identify what are the values which are not covered. So identify those values and identify the smallest value among all uncovered element in the matrix. Then you subtract that smallest value from each and every uncovered element. Then you will get some extra zeros. Then when you get some extra zeros, then you will get extra lines. So that's the first thing you need to do in the fifth step. Subtract the smallest value from every uncovered element, and also we need to add this smallest value at the intersections of the line. If there are some horizontal and vertical lines, there will be an intersection of the lines. Wherever there is an intersection, at the intersection there will be some value. To that value, that minimum value you need to add. Why we are adding? Because in order to avoid selecting that particular intersection 0, because the intersection zeros will have so many options to select horizontal and vertical the columns. So that is why we will be avoiding selecting that intersection. And at some particular point, you will be getting the number of horizontal and vertical lines are equal to the number of rows. Then you assign the task. That is how we are going to solve the assignment problem by using this Hungarian method. Let us see some examples so that you will be understanding clearly. Next step, fifth step says find the smallest uncovered value in the matrix, subtract it from all uncovered element, add it to the element at the intersections of the line. Repeat step 3 to 5 until the required number of assignment is found. Finally, assign the task by selecting zeros, ensuring no row or column get more than one assignment. So here we need to remember 5 points. So if you see the 5 points, the first point, you need to identify what is the smallest element in the row and subtract that all the elements of that row from the minimum value. And in that way, all rows will be, in all the rows, smallest value will be subtracted. So that then you go to the column operation. In the column operation, you first go to the first column and identify what is the smallest value and subtract that value from every element of that column. Likewise, you subtract in all the columns. Then the third step is draw the horizontal and vertical lines such a way that it covers the all zeros. And when you are drawing these lines, you need to draw minimum number of lines. That means where the maximum zeros are there, that we will first draw the line. Likewise, you will be covering by drawing the horizontal and vertical lines. And when you are covering, there are some elements which will not be covered, for example, and let it be. Then if the fourth step is when the number of lines and horizontal and vertical lines together, if the number of lines are equal to number of columns, then the optimum solution is assigned. Then you can assign the task. If not, you need to go to the fifth step. The fifth step says that identify the uncovered elements. I told you, when you draw horizontal and vertical lines, minimum number of lines, then we will not get optimum solution when there are some values are not uncovered. So you identify what are the values which are not covered. So identify those values and identify the smallest value among all uncovered element in the matrix. Then you subtract that smallest value from each and every uncovered element. Then you will get some extra zeros. Then when you get some extra zeros, then you will get extra lines. So that's the first thing you need to do in the fifth step. Subtract the smallest value from every uncovered element, and also we need to add this smallest value at the intersections of the line. If there are some horizontal and vertical lines, there will be an intersection of the lines. Wherever there is an intersection, at the intersection there will be some value. To that value, that minimum value you need to add. Why we are adding? Because in order to avoid selecting that particular intersection 0, because the intersection zeros will have so many options to select horizontal and vertical the columns. So that is why we will be avoiding selecting that intersection. And at some particular point, you will be getting the number of horizontal and vertical lines are equal to the number of rows. Then you assign the task. That is how we are going to solve the assignment problem by using this Hungarian method. Let us see some examples so that you will be understanding clearly. Now let us see one example. For example, you need to purchase 3 products from 3 different suppliers. And if you formulate the assignment problem in a matrix, the matrix is looking like this. There are 3 products, product 1, product 2, product 3, need to purchase from supplier 1, supplier 2 and supplier 3. And the quotation costs are given here. And now according to Hungarian method, we will try to solve this problem. And if you to solve the problem, first we need to go to the first row. Out of these 3 values, elements, which one is the smallest one? The smallest one is 6. So subtract the value 6 from each and every element. Then the matrix will be, the resultant matrix will be like this. So 6 minus 6, it will be 0, 9 minus 6, it will be 3, 12 minus 6, it will be 5. Then you identify the smallest value in the second row, that is 8, and subtract each and every element from the smallest value. So then the resultant row will be 10 minus 8, 2, 11 minus 8, 3, and 8 minus 8, 0. Then identify the smallest value in the third row. In the third row, 7 is the smallest element, and subtract this smallest element from every element in the row. Then the resultant row will be 13 minus 7, 6, 7 minus 7, 0, 10 minus 3, 0. So then this is the after column row operation, this is the resultant matrix. Now you do identify the every column and minimum value. In the first column, the minimum value is 0, and if you subtract 0 from every element, so then it will become the same value. The second row also, second column also subtract 0 from every element, then it becomes the same column. Similarly, the third column also. That means now we got zeros. There are 3 zeros are in different the columns. So if you draw horizontal and vertical lines, so it will be a 3 lines. That means we already achieved the optimum solution. Then you assign. How we assign? Based on the zeros. If you assign the first 0, that means product 1 for say supplier 1, and product 2 to supplier 3, product 3 from supplier 2. Then if you go to the initial matrix and if you see what is the value here, the initial value in the initial matrix here is 6. So you will be adding the 6 plus, and initial the value at this the position is 8 and plus 8, and initial value at this allocation is 7. So the total 6 plus 8 plus 7, this is and that is equal to 21. That is the minimum the cost, minimum purchasing cost. So that is how we will be solving. Let us see one more example with the 5 by 5 matrix. And in a manufacturing company having 5 jobs, that is a P, Q, R, S, T, and need to be assigned to 5 missions A, B, C, D, E, and we need to assign in such a way that the total cost is minimized. Let us solve this problem by using Hungarian method. So now first I will be considering the matrix, and according to Hungarian method, first I will identify in the first row the minimum value, that is 2. So I need to subtract it from first row. Then you go to the second row, third row, fourth row, then you subtract the values. So these are the minimum values, and subtract the 10 minus 2, that becomes a 8. 3 minus 2, 1. 3 minus 2, 1. 2 minus 2, 0. 8 minus 2, 6. Likewise, each and every row, if you subtract the minimum value, this is the resultant, the matrix. Now again, you identify the minimum value in the column. If you identify the minimum value in the column, so the first column minimum value is 1, second column minimum value is 1, third column minimum value is 1, fourth column minimum value is 0, fifth column minimum value is 2. So now subtract the minimum value from column. So now if you subtract it, the resultant matrix will be like this. Now according to Hungarian method, the third step will be, you need to draw horizontal and vertical lines, minimum number of horizontal and vertical lines, in such a way that horizontal and vertical lines will cover all the zeros. Now in order to draw the horizontal line, we need to first see where we have maximum number of zeros. Now if you see, here are the maximum number of zeros. So you draw one horizontal line which is covering 3 zeros. So then you go to another zeros. So here there are 2 zeros and here there are 2 zeros. So now in order to cover, and here there are 2 zeros. So now in order to cover the another zeros, you draw the vertical lines. So now here if you draw vertical line, so it will become the another horizontal line, this is the another horizontal line, and again one more horizontal line we will draw here, which is also covering the zeros. Here also it is covering 2 zeros. Now there is only 1 zero. So in order to cover this zero, you can draw the vertical line, or otherwise you can also draw horizontal line. But if you draw horizontal line, it is only having one intersection. But if you draw vertical line, there are the 3 intersections. So try to draw the horizontal line. So now if you see the number of lines, 1, 2, 3, 4 and 5. So we need the 5 lines. So we got the 5 rows, and that means the number of horizontal and vertical lines are equal to number of rows. That means we already achieved the optimum solution. Now we need to assign. So how to assign? So first we need to see the first row. In the first row there are 2 zeros. So which zero we need to assign to B, and which one we need to assign to B or C, we need to assign to Q. So we can't decide. So both are same eligibility. So that means for Q we can assign B as well as C also. So we can't take the decision. So go to the next row. In the next row there is only 1 zero. So assign the job D for R mission. So that means because there is only 1 zero here in the second row, so you assign it. So here it is very easy to take the decision because of only 1 zero. Go to third row. In third row also there is only 1 zero, so you can assign that 0. And you go to fourth row. In the fourth row there are two zeros, but this zero we can't assign because for third mission, fourth the mission, we can't assign E job because already it is assigned to S. So that means this zero is cancelled. Then there is only one option, that is the first zero, which we can assign to the fourth job, fourth mission. So then you go to the last row. In the last row there are three zeros. There are three zeros, but this zero we can't select because this column already assigned to the T, and this column also we already assigned to the R. So that is why if you see, the only one zero is available in this row. There is only one zero we can able to assign to that is to C. So you assign this 0 to C. So then if you assign this 0 to C, then the remaining 0 is only B. So you assign this 0 to B and this 0 to C. Now we got 5 allocations. So now you go to the initial matrix. At this allocated values, zeros, what is the initial value? That we need to add. All these 5 values, if you add, then that will be the total minimum cost. So initial value will be 3 over here, 2 over here, 3 over 4 here, and 3 plus 9. So total the answer will be 21. So that is how we are going to solve according to Hungarian method. Let us see one more example such that you are able to solve any type of problem. Let us see another example. So in this problem, there are 5 type bits. We need to assign to 5 services such a way that the total cost will be less. So here first we will solve this according to Hungarian method. So if you see, there are 5 rows and 5 columns. So here first in the first row, the minimum value is 65. So 65 need to subtract from every element, and in the same manner for all the rows. Then the resultant matrix will come like this. So 85 minus 65 20, 75 minus 65 10, 65 minus 65 0, 85 minus 65 20, 75 minus 65 10. So similar manner for every row, if you subtract the minimum value which is in this column, so you will get this matrix. Now again we need to subtract the column minima from every column. So for example, if you take the first the column, the minimum value is 18. So 20 minus 18, it will become 2. 24 minus 80, 18, 6. And 18 minus 18, 0. So 20 minus 18, 2. 20 minus 18, 2. So like that, for every column, the minimum value need to be subtracted from every column, every element in the column. So likewise, if you do, this is the resultant matrix. Now the third step is we need to draw a minimum number of horizontal and vertical lines
such a way that these horizontal and vertical lines need to cover all the zeros. So now first I need to see where the maximum number of zeros are there. So if you observe all the rows and columns, column 3 is having more zeros. So I will draw one line here by joining all the zeros. Then if I see the fourth row, so last row, fifth row, there are three zeros. So because here there are three zeros, to cover all these three zeros, I will draw another horizontal line. Then if I see there is only one zero here and one zero here, whether I need to draw another vertical line or horizontal line. So even if you draw a vertical line or horizontal line, so the number of lines will be only 4, but the number of rows are 5, because the number of lines are not equal to number of the rows. I need to go to fifth step. Fifth step says we need to first identify the uncovered elements by the lines. So these are the red color, the elements are not covered by the lines. So the out of these uncovered elements, identify which one is the lowest number element. So the 2 is the lowest element, so subtract 2 from every uncovered element. If we subtract the 2 from every uncovered element, the resultant matrix will be like this. So 6 minus 2, 4, 4 minus 2, 32, and 8 minus 2, 6, 2 minus 2, 0. So likewise, all red color, the numbers will change. And wherever there is an intersection of the lines, there we need to add this minimum value. So here at 0 we need to add 2, so this value become 2, and this intersection will become 2, this intersection also will become 2. Now remaining all lines, remaining all elements, wherever there is a the lines are passing, other elements will be as it is. Only uncovered elements will be subtracted by the minimum value of uncovered elements, and wherever there is a intersection, there the minimum value will be added. Apart from that, remaining all elements will be as it is. Now again we will try to draw horizontal and vertical lines to cover all the zeros. Now if I draw the minimum number of lines for joining all the zeros, so these are the minimum number of lines. So here I am drawing one line to cover these two zeros. To cover these three zeros, I draw another line, another line, another line. But the number of lines are only 4, but the number of columns are 5. That means optimum solution not yet reached still. So that means I need to further do the repeat the step 3 to 5 again. So now if I consider this again, here now these are the uncovered elements, and then these are the junctions. Again the procedure will be same. So identify the uncovered elements by the line, and identify whichever is the smallest one, that is 2, that is 1. So subtract 1 from every uncovered element. Then and again this you add 1 at the intersection of the lines. Then you will get the new matrix. Now when you are after you get the new matrix, because it's 1 minus 1, here you will get extra 0, and again at the intersection the 3 you will be getting. So now if you draw the horizontal and vertical lines again, so here these are the horizontal and vertical lines. Now if you observe, total number of lines are 5, but total number of rows are 5. So now the total number of rows is equal to number of lines, so we will get the optimum solution. Now you assign the task. Now you go to how to assign. So first you go to first row. In the first row there is only 1 0, so that means in this the row at least 1 0 should be allocated. So that 0 will be this 0, so allocate this 0. Then the next row there are 2 zeros, but this 0 already allocated to E, so this 0 we can allocate it to Q. Then you go to third row. The third row, this 0 and this 0, both zeros are having same possibility to select. So we can't select or assign any A or B to R. Then you go to next row. In the next row there are three zeros. Out of three zeros in this column already this one zero is allocated, so this we can't select. And in this column there is one more zero is allocated, so this zero also cannot be assigned. So only one zero is left which we can able to assign to A. So select this zero. Then you come to fifth row. In the fifth row there are two zeros. Out of these two zeros, we can't select either this or this because both having a same the priority. Then you come to column. So if you come to column, in this column, so zero is there but already allocated. So allocated columns if you remove, if you eliminate, only two columns are available here. Out of these two columns, here there are two zeros. I can't select any one zero because both the zeros will have a 50-50% to be selected. Then if you come to fourth column, there is only one zero. This need to be selected. So you assign this zero to D, and then obviously for the other zero will be this. So here this zero I can't assign to B, so this zero will be assigned to B. So now I got total 5 allocations. So at these zeros, what is the initial value in the initial matrix, that I will first identify, and then if I add all the values, that will be 359. So that is the total minimum cost. In this way, we need to repeat the procedure according 3 to 5 till we get the optimum solution. So, but there are some special cases in assignment problem. So that is the maximization problem. So till now we have seen only the minimization problem, but in some situation the assignment problem may call for maximization of profit, sales, revenue, etc. For dealing with such problems, we first change it into an equivalent minimization problem, and this is achieved by subtracting each element from the highest value in the matrix and then solve the problem by Hungarian method. Why we are using Hungarian method here? Because the Hungarian method we can't use for directly maximization problem. So that is why we are going to convert that maximization problem into minimization problem, and then we are applying the Hungarian method. Let us see one example. So according to this example, a company wants to assign 4 workers to 4 tasks to maximize the profit. The profit matrix is given in the table. So here the profit we need to maximize. So when you want to maximize the profit, so here we can't actually assign the Hungarian method. So for that reason, we need to see the entire matrix. In the entire matrix, we need to identify which one is the highest value. So highest value is 60. So in order to convert this maximization problem into minimization problem, first find the highest value and subtract each element from the highest value. So if you subtract each element from the highest value, then the matrix will be converting like this. So first it will be 60 minus 42, that is 18, 60 minus 60, 0, 60 minus 35, 25, 60 minus 41, 19. In that way, every row and every column, every element will be subtracted from highest value. Because this is the highest value, all this value will be in positive. So then we have correctly identified the highest value. Then now this becomes the minimization problem. So now you can apply Hungarian method to solve this matrix. Then finally we will be getting the maximization problem. So now if you apply Hungarian method to this matrix, identify the minimum value in the row, that is 0. Then in the second row, that means 0 means, so values will not change. And the second row, the minimum value is 13. So you subtract 13 from every element. 35 minus 13, 22. 27 minus 13, 14. 13 minus 13, 0. And 25 minus 13, 12. In that way, here the minimum value is 10 and in the fourth row minimum value is 8. So finally you will be getting this matrix. Then you identify the minimum value in the column. So here the minimum value is 0, here the minimum value is 0, here the minimum value is 0. So these three columns, no values will change because we are minimum value itself is 0. In fourth column, the minimum value is 6. So subtract 6 from every element, then the new matrix will be like this. Then now you draw the horizontal and vertical lines such that you will be getting the minimum number of lines. So now if you draw horizontal and vertical lines, there are 4 lines and there are 4 columns and rows. So we reached the optimality. So now you assign PQRS to ABCD. Now if you come to first row, in the first row 0 is here, so you assign that 0, only 1 0 is there, and in second row there is only 1 0 is there, assign that 0, and third row 0 is here, but this 0 is cancelled because of allocation of the first 0 here, then only 1 0 is left and that 0 will be assigned to D, and finally this 0 will be assigned to A. Now we need to maximize the profit, so the maximum cost or profit is equal to, and you need to go to the initial table. In the initial table, here we are having whatever the value is here, that value we need to keep here, that is 60, and in the initial matrix, that means in the initial profit matrix, here that's 47, here 44, in this place 52 is there, so the total 203 is the maximum profit. So that is how we can able to solve the maximization problem. And let us see the another special case, that is unbalanced problem. If the number of rows is not equal to number of columns, then the problems will be unbalanced problem. And in this case, we add a dummy row or column whichever has deficiency with the zero cost. Then we will solve the problem as usually. Let us take this example. In a company, there are 3 workers, W1, W2 and W3, but there are 4 tasks, T1, T2, T3 and T4. The cost matrix is given, but now we need to assign. How can we assign 3 workers with 4 tasks? That we can't assign. That is why we will be adding one more row, that is W4 with 0 cost. Then it will become the 4 into 4 matrix, then we can able to solve this problem. So now let us consider a dummy row which is W4 with 0 cost. Now this becomes a square matrix. Now you solve the problem by applying the Hungarian method. So then we will subtract the first row with the minimum value, so that is 25. So 40 minus 25, 15, 55 minus 25, 30, 25 minus 25, 0, 45 minus 25, 20. In the similar manner, in the second row, this is the minimum value, you subtract the second row, every element you subtract 25, and in the third row every element you subtract 20. So then you will get the new matrix. Now you need to do the column operation. In the column operation, the fourth column is having a 0 0, then all after column operation the values will not be changing. So now we need to draw horizontal and vertical lines. Then if you draw horizontal and vertical line, and there are only 3 lines, but we have 4 the rows. That means I need to repeat. I need to go to fifth step. The fifth step says that uncovered elements I need to observe. Out of all uncovered elements, which one is the minimum? The 5 is the minimum value. That value I need to subtract from every element. So if I subtract it, then I will get the new matrix, that is 0, 15, 5, 20, 25 and 15. So then now again this small minimum value we need to add at the junctions, at the intersection. So here at the intersection if you add, it will be 20, and here this point will become 5. Now you draw the horizontal and vertical lines. This is the horizontal line which is covering 3 zeros, and this is the vertical line, 2 zeros, 2 zeros, and one more zero it is covering. Now the number of horizontal and vertical lines are 4. Now we can assign the task. Now again, how to assign the task? You go to first row and there is only 1 0, so you assign to task 3. And the worker 2, there are two options. We can assign task 1 and task 2 also. So go to the next row, the W3, worker 3, we can assign only to task 1, so you assign there. Then you go to fourth row, but there are 2 zeros, so we can't assign. So then you go to the second row, and there are 2 zeros, but this is already assigned, so then we can assign task 2 to worker 2. Then finally the left out 0 will be assigned to task 4. Worker 4 will assign the task 4. Now if you go to the allocated cells, if you see, and initial cost, then the total cost will be 75. In this way, unbalanced problem will be solved. And then there is another special case, that is negative cost. Hungarian method is primarily designed for cost minimization problem where all costs are non-negative. However, if the cost matrix contains negative value, the method can still be applied after making a suitable transformation. Find the most negative value in the cost matrix, add that absolute value of the most negative element to all the elements in the matrix. This transformation ensures all values are non-negative, and then we will follow the steps as usual. And there is an impossible assignment also, that is vacant cells. If some assignment be impossible, that is if the some job cannot be performed by some particular facility, then we can avoid this effectively by putting a large cost that is infinite in that cell, which prevent that particular assignment from being effective in the optimum solution. Note that an assignment problem may have more than one solution having the same minimum cost. So if you put a large cost that is infinite, that cannot be selected because that is a large cost. So that is how we are going to avoid this, whichever the task is impossible. So finally, I am concluding from this assignment problem that the assignment problem is a key optimization challenge in operations research, focusing on assigning task to agent to minimize cost or maximize profit. Hungarian method highlights the importance of efficient problem solving approach in real world application. It also suggests potential new directions for addressing practical real life problems through optimization techniques.